Welcome back, scholars. Let's continue our investigation of ratios and proportions with an example. Example number 1, the ratio of the side lengths of triangle DEF and triangle ABC is 3 to 1, meaning all of these sides are 3 times as big as the corresponding sides in the smaller triangle. Both triangles are right triangles, with the right angles occurring at angle A and angle D, respectively. AC is 12 units long and DE is 15 units long. Can we find the missing side lengths? Alright, well, let's fill in what we already know. AC, same as CA, is 12 and DE is 15. DE corresponds to AB, that's why they're stacked on top of each other. EF is the hypotenuse, corresponds to BC in the smaller triangle, and CA corresponds to FD. Alright, so we have our corresponding side lengths stacked on top of each other. We know the side lengths in DEF are 3 times as big as the side lengths in ABC. So that means DE is 3 times the length of AB. So AB is DE divided by 3, or 5. Cool. CA is the smaller one. So we know FD is 3 times as big as CA. So FD is 3 times 12, which is 36. Let's label the things that we know. Now we have AB is 5. FD is 36. Now we need to find the hypotenuse of each side. How are we going to do that? The Pythagorean theorem. A squared plus B squared equals C squared. Let's find the hypotenuse of the smaller one first. So we'll do 5 squared plus 12 squared equals CB squared. 5 squared is 25, 12 squared is 144, CB squared. Add those together, we get 169 is CB squared. Take the square root of both sides, and we get that CB is 13. 13. CB is the same as BC. So then we know that EF is 3 times as big as BC. 3 times 13 is 39. Cool. All right. Now a proportion is an equation that equates means sets equal to ratios, aka fractions. So here would be an example of a proportion. A over B is equal to C over D. We've got special names for each of these letters. The means are the middle number of a proportion. So say we have this proportion A to B, which could also be written as A over B equals C to D, also known as C over D. The means are the middle numbers, A and B. A and B. So the means are B and C. I kept saying A and B. I meant B and C. The extremes are the outside numbers, or the last numbers. So again, in the proportion A to B equals C to D, and that's the same as A over B equals C over D. Our extremes are A and D. A and D. A and D. Okay, cool. Moving along. Looking strong. The properties of proportions. The cross product property tells us that the product of the means is equal to the product of the extremes. Okay, so that means in our proportion we were just looking at, A over B equaling C over D, the means, the product of the means would be B times C equals the product of the extremes, A times D. A times D. There you go. And the reciprocal property says if two ratios are equal, then their reciprocals are also equal. Reciprocals are also equal. So that would mean if we have two ratios that are equal, like A over B equals C over D, we could flip it around and that same thing would be true. B over A would equal D over C. Okay, great. Let's do some examples using our cross product property. Example number 1, 8 over x equals 1 over 2. We can use our cross product property, meaning we can do x times 1. X times 1 equals 8 times 2. Our means times our equals the product of our extremes. X times 1 is just x. 8 times 2 is 16. Don't have to do anything else fancy. There we go. Okay, cool. Number 2, same idea. The product of the means, y plus 4 times 1. Y, I want that to be a y, plus 4 times 1 equals 5 times y. Our means times our extremes. Well, y plus 4 times 1 is just y plus 4. And 5 times y is 5y. So let's subtract y on both sides. And we'll get 4 equals 4y. Divide by 4, and we get y equals 1. You can do number 3, exact same way. And now we've got some word problems to do. I'll help you set up number 5 and let you go. In the School of Athens, one of the most famous paintings by Renaissance painter Raphael depicts the greatest minds of the time. Plato, Aristotle, Socrates, and our favorite Pythagoras are among others. The real height is about 500 centimeters. Approximately how wide is the painting? So we have the height versus the width. The height versus the width. Let's do height over the width. Okay, so our height is 2 inches. Our width is 2.5 inches. We're saying the real painting, which is to scale, has a height that's 500 centimeters. And we're trying to figure out the width in centimeters of the new painting. So you're going to do your cross product property. 2.5 times 500 equals 2 times x, and solve for x. All right, scholars, you got it. Keep up the good work.